Okay, we need to talk about the distinction between research methods and statistical methods because these get confused routinely. So, statistics are how you tell whether a pattern does exist in a set of observations. But a statistic can only tell you that a pattern exists. It can't tell you why it's there. In other words, a statistic can never prove a guess, right or wrong. That's the job of experimental controls. So, as Stand Up Math says on YouTube, this mistake is like hearing your smoke alarm go off in your house and immediately filing a claim with your insurance company for replacement of all of your goods. Well, the smoke alarm is going off. That proves the house is on fire, right? No. Someone might have burnt some toast. Someone may have taken a heavy shower. There may be blowback from a barbecue grill outside, or your house could be on fire. You don't find that out by looking at the smoke alarm. You find that out by observation of the surroundings. And people make this mistake all the time. You will see people routinely interpreting a statistical test as proving that a guess is right or wrong. We'll get more of that later. So statistics get you from observations to connections. Experimental structure gets you from guesses to a story. And in case you're wondering, the only thing that gets you from connections to guesses is creative thought. That's the fun part of research. So in the 1960s, Robert Rosenthal made an interesting observation. In his department of psychology, all of the experiments confirmed the going-in hypothesis. And he thought, there's something funny going on here. That doesn't happen in physics and chemistry. Those guys' experiments routinely confound what they're expecting to find. Why isn't that happening in psychology? So he began watching how he and his peers went about carrying out their research, and he found the Rosenthal expectancy effect, which today we would call a form of confirmation bias. So what he noticed is that in structuring the experimental controls, his colleagues made a great many decisions, like how they pick their control and experimental subjects, how they choose their measures and their rules, do the manipulations, time data collection, decide that their study is over, and many other decisions. They assumed that these choices would not bias the experiment because they did random assignment and they had a p-value. But these things have a powerful impact on what they're going to find. So for example, my first week of graduate school, I was given a handful of studies to read for class, and this was the first study in the packet. Stigmatization of AIDS patients by mental health professionals. See, the researchers assumed that there was guessed that there was a great deal of undetected bias in mental health professionals toward people carrying the HIV virus. Well, that would be a pretty important thing if it were there. So they mailed out vignette and questionnaire packets to mental health professionals in cities that had high HIV infection rates. The vignettes were identical, except the person is dying of either AIDS or leukemia and is either straight or gay, counterbalanced. And look at that table there. Well, I mean, they got a lot of significant results. Look at all those stars. So in their discussion, they say the psychologists and social workers consistently held negative biased attitudes toward people with AIDS, which would probably manifest themselves in behavior. Okay, so this table is 12 actual Likert scale items, where a higher score indicates greater disagreement. And if you look at that first item, yes, the behavioral health people said that the AIDS patient was more responsible for his illness than the leukemia patient. And I thought, well, yeah. I mean, how do you get leukemia? There are voluntary behaviors by which you can contract the HIV virus, but if you set out as a goal to get leukemia, what would your behavior be? I mean, do you eat plutonium? The real news here is that there are some behavioral health professionals who think that leukemia patients are a little bit responsible for having leukemia. What is that about? And notice it's a 7-point Likert scale. They're more disagreeing than agreeing. And I thought, why did you pick leukemia as your contrast condition? This is an aspect of the Rosenthal effect. Why'd you pick leukemia? What if you had picked diabetes? Or if John either had AIDS or was a smoker who was now dying of COPD? Would we get the same results? But it's even worse. The BHPs thought the AIDS patient deserved more sympathy. AIDS is more traumatic than leukemia. The world would be less well off if John died. They interpreted their effects in the wrong direction. Well, let me tell you, that was a great lesson for the first week of graduate school. What I learned is you have to read articles carefully. Don't assume the experimenters got anything right. Check their work. I have never seen a correction or retraction to that study, but I did see it used in a later meta-analysis where they didn't even notice that the effects were reversed. Now, the issue here is the difference between directional and non-directional motivations for doing research to begin with. Now, we talked about how many observations you have to make to ground good study. Observations extend years or decades, and you have to have a pretty strong motivation to do that kind of detailed, tedious, plodding work. There are non-directional motivations. You may simply be curious, or you may be fired with the thrill of the unknown, like Charles Darwin was. You may be inspired by a sense of wonder. Or I've noticed there's good research done by people who have a condition on the condition they have. For example, Marsha Linehan actually had borderline personality disorder, and she created her treatment for it in part because of the poor treatment that she herself got when she needed it. People with non-directional motivations tend to be skeptical toward their own ideas because they want to find the truth. And then you have directional motivations, the desire for glory, advocacy for a group or a position, a political ideology, or antagonism to some other scientist you happen to dislike. When observations are colored by directional motivations, the researcher usually discovers the preconceptions and announces them to the world, and the real threat is that if others share that same directional motivation, they can form a scientific cult and create a zombie theory. So you've probably heard of stereotype threat. Stereotype threat doesn't exist. These two studies showed the flaws in the original research, and this one made me angry in particular because I read the original article when it came out, and I did not notice the key fact about the graphs in that article that announced that they had manipulated the data so as to create the appearance of an effect where there was none. These authors will enlighten you. Stereotype threat is a zombie theory. Social priming does not occur. The Zimbardo prisoner and guard study was deeply rebutted in October 2019 American Psychologist. This is a study that just needs to go away because of the flaws in it. Ego depletion doesn't happen. I would put eye movement desensitization and reprocessing out there as a zombie theory myself. I think the evidence is clear that what's new in it isn't good and what's good in it isn't new. Learned helplessness is a counterexample. After 50 years of research, Marty Seligman published this article in Psychological Review in which he gleefully announced that his original theory was exactly backwards from what happens in nature. That's a non-directional motivation at work. He's happy to find out he was wrong because he wanted the right answer. Special focus on power posing. This is the theory that people's body postures actually affect their hormonal balances. So if you take large space-occupying alpha gorilla positions like arms akimbo, like her right arm is there, before you go into a stressful situation, It will not only put you in an alpha gorilla frame of mind so that you will present yourself well, it'll actually change your hormone balances. Well, in 2010, the first article came out. 30 replications came out over the next few years. In 2012, Amy Cuddy recorded her TED Talk. She published her book in 2015, and by 2017, hers was the most watched TED Talk ever. Meanwhile, back in science land, these authors found that power posing might change how you feel, but it doesn't actually change behavior or hormone balances. And the next year, if you double blind the study properly, you don't even find that. These people reanalyzed the original data and found that if you just change how the outliers are handled, the entire effect goes away. And these people tried closed-in yoga poses, and they work just as well as expansive power poses. Power poses do not help with social phobia, and these people did a probability curve analysis on all the published research to show that the many published studies are finding random effects. Remember that one. That one's going to come back at you in a couple of minutes. So the outcome is that the lead author in 2016 repudiated power posing because the evidence was overwhelming. But the book and the TED Talk were still available, and you have a new zombie theory. Confirmation bias is public enemy number one for good experimental methods. Confirmation bias corrupts the top half of the pyramid, and doing the bottom half correctly cannot correct that. Confirmation bias means you phrase your research question so that if you find an effect, it will confirm the hypothesis. Anti-confirmation bias is to design your experiment so that if you get a significant p-value, it proves your hypothesis wrong. And the best of all is to conduct Thunderdome research, where you design an experiment so that two explanations go in and at least one of them will be forced to be disconfirmed. That's called a critical experiment. I like the idea of Thunderdome research. So the third checkpoint when you're reading research is beware of the Rosenthal effect. Have extra skepticism in the face of perceived directional motivations. Extra skepticism in the face of flashy findings and trendy things. Ours is a boring field. What I mean by that is that when you're treating people 10 years from now, you're going to be asking a depressed person, so did you say 3 nice things to yourself every morning? And did you go to that party that we talked about? Okay, let's do an ABC thinking report on how you talked yourself out of going to that party. And you're going to think, my God, I'm sick of doing the same old thing over and over. Too bad it works. And we are all motivated to find the next trend, the next flashy form of treatment to break up our own boredom. Beware of that directional motivation. So just lately, I've been getting emails advertising brain spotting, the powerful brain-based trauma therapy that accesses the deepest regions of the brain, yada, yada, yada. And for a mere $1,500, I can become a brain spotting expert. Needless to say, I'm not giving them my money. They can go through the research loop just like everybody else and prove that this is actually effective. And because they're motivated by money, I'm going to have extra skepticism about their research because that's just plain prudent. Look for the confirmation bias built into experimental design. Did they design their study so that a finding would prove them right? Or did they design their study so that a finding would prove that they were wrong? Look for a review article or a rebuttal written by a methods expert. So you remember the one Simmons and Simon John used probability curve analysis? Well, I pulled up the original power posing study and clicked on the link in Google Scholar to show everything that cited this, looked through the titles, and one of the titles mentioned probability curve analysis. Now, at that moment, I didn't have a clue that probability curve analysis even was a thing. But when you see a nerd word like that in the title of a content article, you're looking at some statisticians who are highly motivated to describe a method in a way that you and I can understand. So I read that article, and I can't do a probability curve analysis, but I understand the method enough to get what they're doing. And it's actually a very clever way of looking for bodies of research that are just driven by the need to find a p-value without any actual underlying results. I'd like to see a probability curve analysis of anger management, let me tell you. And you can look at replication index and a couple of other resources like Stack Exchange. There are several YouTube channels that will teach you more about methods expertise. By contrast, you can afford to have extra confidence when you find authors who've tested the reverse of their hypothesis, or have tested several different hypotheses and retained the best fit, or have paid very close attention to true double blinding. Never accept their word for it that a study was double blinded. Always ask yourself, is there any possible means by which a subject or an experimenter might have been able to see through the double blind? And the number one way this happens is the use of an inert placebo, so that if you're having side effects, you can tell you're in the experimental group. Or have extra confidence in those who used an unusually rigorous method rigorously, like the critical experiment Thunderdome research, or the method of universals, such as Lonnie Athens or Stanton Samanow did, or people who have publicly and visibly changed their minds based on the evidence. Here are a couple of popular press books that will give you insight into proper research methods.
For a very long time, people believed that geese grew on trees. All because of this, the goose barnacle, and its passing resemblance to this, the barnacle goose, so named because, well, you see, people in medieval Europe observed two things. One, they would often find goose-ish looking barnacles in the water attached to pieces of driftwood, and two, despite the fact that they saw barnacle geese living around them during much of the year, during the summer they could never find any barnacle goose eggs or catch any barnacle geese mating or building nests. So they put one and two together and came to the conclusion that the wood with the barnacle on it must have come from a tree branch, and that the tree branch must have come from a goose tree, and that it must have fallen out of the goose tree into the water before the goose bud could finish growing into a full-grown goose and fly away. The missing piece of the puzzle was migration, something that science would not explain until several centuries later. And without that one crucial bit of knowledge, the belief that geese grew on trees lasted for a very long time and made its way into some very nice-looking books. They had reached a conclusion, and then they came up with a story to explain it. And this sort of backward thinking used to explain a whole lot, actually. Learned people going all the way back to Aristotle believed that flies came from tainted meat, and that mice came from piles of dirty rags, and that the source of diseases like cholera was the stinky air that people who died of cholera tended to produce. Thanks to science, you know that none of that is true, and you also know that you aren't in the center of the universe right now, or even in the center of the solar system, and that if you come down with a fever, you should probably reach for a pill instead of a knife. But have you ever wondered why you needed science to tell you those things? Just like the people who believed in goose trees, your natural way of understanding the world is to start with a conclusion and then polish and protect that conclusion with biased observations. Science keeps you from becoming too attached to your assumptions by subjecting them to as much abuse as possible. It forces you to look for evidence to the contrary. It seeks the truth by revealing the false. Over the years, this method has eliminated so many ridiculous hypotheses that in a few generations your species went from burning witches and drinking mercury to mapping the human genome and playing golf on the moon. Just know for now, your hamster wheel of limited knowledge will keep spinning unless you challenge your beliefs on a routine basis. Luckily, scientists all over the world are doing that for you right now, for flavors of ignorance you've yet to even discover. And that's why you don't believe that geese grow on trees, and why, in general, you are now less dumb.